Hi physics students, welcome to hopefully the last video in electric fields. And in this case we're going to look at Faraday cages, which you'll hear mentioned about, and they have a wide variety of uses and they're all about electric fields. So a bit of writing here, I'll quickly summarise it, but make sure you pause it and have a read of it. Hopefully it's legible for you. So Michael Faraday invented what's called the Faraday cage. It's an enclosure that blocks electric fields, basically. And it's usually made of a mesh of conducting material. So it doesn't have to be solid, it just has to be a mesh of something, usually wire or steel. And electrical charges, what happens is that any electric field, it prefers to go through the conducting material than go through the space inside the mesh. So effectively inside the cage you get no electric field. Even if you're surrounded by a very strong electric field, inside the cage the electric field hits the cage and then goes around the conductors and then out again. And so it's a way of protecting material. So down here we've got it to protect electrical equipment from lightning strikes and other electrostatic discharges that might occur. They shield the interior from external electromagnetic radiation, and they can also contain electric fields. I forget that sometimes, but when we look at the example of a microwave, we actually have a Faraday cage in the microwave that stops the microwave from getting out. So some real live examples. If you're using your mobile phone or radio, when you go into a tunnel, there's not many tunnels in Tassie, but if you do, you lose your reception. If you're inside an elevator, which is a metal box, you can lose reception. If you're in a concrete building that has steel reinforcing, can all act like a Faraday cage. Here we are, the cooking chamber in a microwave is a Faraday enclosure. So when you look at your microwave, you can look through the glass window. If you look closely at that glass window, you'll actually see there's a mesh, and that metal mesh is got holes in it, and those holes are specifically designed to let you see in and out, but not to let microwaves through. And the metal mesh is conductive. You can get these things that protect your passport and credit cards when you're travelling, and they've got to go through some sensors. They can protect them from strong electromagnetic fields. And some buildings, like the FBI building in America and other national security buildings, when they're built nowadays, they're built with Faraday cages for the whole building, and then even different rooms have their own inbuilt in the walls Faraday cages. And it's a way of stopping people electronically spying on you. And also, one of the things about nuclear attacks is nuclear weapons produce what's called an electromagnetic pulse, and that's a very strong electric field and magnetic field, but we're doing electric fields. Very strong electric field, and that can fry up electrical appliances. Basically you suddenly generate a whole lot of currents in your circuit boards, and the currents are going places that shouldn't go, and it just fries them. And so these buildings have Faraday cages to protect them from that sort of thing. And the same happens with certain military aircraft. The electronics in those are protected from the electromagnetic pulse by Faraday cages, so that if you're flying a helicopter, you might get the shock wave, but the electromagnetic pulse, if you didn't have Faraday cages protecting all your computers and electronics, your helicopter would just drop from the sky. Alright. Here's a whole lot more reading. A UK teacher, like many teachers, gets annoyed by mobile phones being used in class, so he suggested lining every room with a Faraday cage, and that way you wouldn't get any mobile phone reception. Not a bad idea. Cars and planes can act like Faraday cages. I think there's some videos of cars and planes and things being struck by lightning, and the lightning travels around the metal shell rather than going through the occupants. So if you're in a car hit by lightning, you're protected by the Faraday cage, which is the metalwork around you. And I'll show you on the OneNote, there's a video where Richard Hammond sits in a car and gets zapped by 800,000 volts of lightning, and he survives. Oh, I just gave the ending away, but we knew he would survive. So have a look at that, that's quite a good one. Mythbusters, the show, have used Faraday cages in a variety of situations where they want to stop mobile phones being triggered accidentally or sparks occurring accidentally. They use them quite often. The National Radio Observatory, Astronomy Observatory, uses Faraday cages to protect vital equipment, so it's not getting interference from the telescopes or generating interference that might get in the way of the radio telescopes. These aren't optical telescopes, they're radio telescopes. And then there's a couple other videos showing a Faraday cage and another Faraday cage, and then this video, man fights Tesla coil. Let's just bring it across. I'll show you this quickly just to explain what's happening. So that's a Tesla coil, and this guy's in sort of like a suit of armour, and those are real live sparks hitting him. And clearly he's okay.
Alright, let's see how he did. Is he okay? How do you feel?
Feels great.
No burns, no electrocution?
I think that's last night.
Alright.
There you go. So I'll just pause it there, and what you should see, he's wearing, where's my pen gone? Alright. He's wearing a something like a suit of armour, chainmail, stainless steel or something, mesh, covering his whole body, and so when he's getting the current or the charge coming from the Tesla coil, it's going around his body but not through his body, and this wire here is his earth, and so all the electrons are then going into the earth, and he's protected by that. So very neat example of that. And so have a look at those videos. Then there's another video where another guy wears a metal suit for his job. He works on high voltage power lines. That's probably what I should have said. And he crawls along these power lines cleaning the terminals. And if he didn't wear his metal suit, mesh clothes, he'd be electrocuted every time he got on and off the helicopter. And there's some really nice images of him getting on and off the helicopter, so have a look at that one, it's well worth watching. And quite a few people who work with electricity have to do this sort of wearing Faraday suits basically to protect themselves. And as I mentioned before, the Top Gear Lightning video will be on the OneNote as well. Alright, so wait for it. Got giddy. You should be able to do all these questions in your workbook now, and that pretty much ends electric field. So make sure you ask any questions about your understanding in class. Cheerio.